completing calculations using prefixes. I'm going to use 3 examples for this, and that is finding the perimeter and area of a rectangle, the volume of a cuboid, and the area of a circle. And this will also illustrate the use of significant figures and appropriate significant figures in calculations. So first of all, we'll look at the perimeter of a rectangle. If we have a rectangle that is, let's say, 6 centimeters by 5 centimeters, the perimeter of that would be 6 centimeters plus 6 centimeters plus 5 centimeters plus 5 centimeters, which is going to be 22 centimeters. Now that's usually perfectly acceptable, but if we wanted the answer in meters, we'd have to then convert that, and we'd say that is 22 times 10 to the minus 2 meters, which is going to be 2.2 times 10 to the minus 1 meters. To find the area of the rectangle, we've got that the area is 6 centimeters times 5 centimeters, which we could just have as 30 centimeters squared. If we wanted it in centimeters squared, that's perhaps the way that we'd do it. To get to meters squared, there's 2 sensible ways of doing this. One is we could convert the original values into 6 times 10 to the minus 2 meters times by 5 times 10 to the minus 2 meters, and that would then give us 30 times 10 to the minus 4 meters, which we could call 3.0 times 10 to the minus 3 meters squared, of course. Or we could, from this value over here, we could say that that is 30 times 10 to the minus 2 meters all squared. And we have to be careful here that we square everything inside the bracket, because that will also give us 30 times 10 to the minus 4 meters squared, which leads us back up to the same answer as we had before for that. Now if we take, instead of that, we're going to look at a cuboid, and this time if we have a cuboid that is a thin slice of material such as that, and if we say that that is about 0.1 millimeters thick and 5 millimeters high and 8 millimeters long, in that case, if we wanted to find the volume of that cuboid in millimeters cubed, we would simply do 0.1 millimeters times by 5 millimeters times by 8 millimeters, and we would end up with our answer straight away of whatever it is, 4 millimeters cubed. 4 millimeters cubed. That might be good enough for us, or we might want to make that into meters cubed. And again, we can use both of the approaches that I mentioned above. Simple approach that I'm going to use for this one is I'm just going to do, that's going to be times 10 to the minus 3 meters all cubed, and in this case that will become 4.0 times 10 to the minus 9 meters cubed. And when we start getting negative indices and multiplying them together to get cubes, we can end up with quite small looking numbers. 4.0 times 10 to the minus 9 sounds like a tiny number, but when we consider that there are actually 100 million millimeters cubed per meter cubed, then it starts to make sense that that is actually quite a small number. If we take the example of a circle, and if we say that that's a circle with radius 2.6 centimeters, in this case we know that the area of a circle is pi r squared, so it's pi times 2.6 centimeters all squared, and that then becomes, straight away if you multiply it out, and we get 21 point, and if we use all the decimal places that the calculator gives us, 2.371664 centimeters squared. Now clearly that's crazy. The question was only given to 2 significant figures, 2.6 centimeters, so we can't quote the answer to a greater precision than the question. So in that case that would just become 21 centimeters squared. And again, we can convert that straight away. 21 times 10 to the minus 2 meters all squared, 21 times 10 to the minus 4 meters squared, which then becomes 2.1 times 10 to the minus 3 meters squared.